This video lesson is on vectors. By the end of this video, I want you to be able to know two different things. The first is to differentiate between what we call a scalar quantity and a vector quantity. The second is to know how to be able to graphically represent a vector quantity. A quantity is something that you measure. Some quantities have only size, and we call these scalar quantities. Some examples would be time, temperature, mass, or distance. Some quantities, however, have both size and direction. These are known as vector quantities. Some vector quantities that we've already talked about this year are velocity, acceleration, and displacement. Okay, so let's get into a little bit what is a vector. Again, vectors are quantities that have size and a direction. If I'm representing a vector quantity, so for example, velocity, I could say I was driving 35 meters per second to the north. I've got my size, that's represented by the 35 meters per second, and I've got my direction as indicated by north. If I talk about acceleration, our free fall acceleration is 9.8 meters per second squared. That's the size. The negative would indicate direction. Or displacement, we can talk about how far, so 50 paces, and then the direction would be to the east. When I go to express a vector on paper, the size of a vector is a number, and so is the direction. So let's take a look at a vector that's 38 meters per second in a direction of 52 degrees. The way that I want to represent that on paper is with an arrow. If this were my vector representing the 38 meters per second, the length would represent 38 meters per second. The angle is measured relative to the x-axis. What if I wanted to represent a vector that was only half the size, so going 19 meters per second? Well, then I just draw it half the size. So this vector would represent 19 meters per second, still at a 52-degree angle. We can express angles in a lot of different ways, but the standard convention is to express the angle relative to the positive axis. If you set up your coordinate grid system just like you would in a math class, this is your positive x-axis. Anything in this first quadrant would represent 0 to 90 degrees. Continually moving counterclockwise, this is your 90 to 180 degree range. The third quadrant is 180 degrees to 270 degrees. And finally, the fourth quadrant is anything from 270 to 360 degrees. So again, we always start at the positive x-axis and move counterclockwise to measure our angle. Okay, so let's look at a few examples. If I set the scale as 1 inch represents 10 meters, I want to know the value of this following vector. First thing I need to do is measure this vector out. So that vector is 2 inches long. Using our scale of 1 inch equals 10 meters, this vector would represent 20 meters. I also need to represent the angle. Okay, so using our protractor, this vector would be a 20-meter vector at about 41 degrees. What this vector is it's actually a displacement vector because we're measuring in meters. So it's how far you've gone, that's the 20 part, and in what direction, that's the 41 degrees part. Let's try another one. Using the same scale, what would this vector represent? Your first step is to measure it. I'm going to call this 1.5 inches, so my displacement would be 15 meters. Then I need to bring out the protractor and measure the degrees. So this vector would represent a displacement of 15 meters at 130 degrees. I could also say this is 15 meters, 50 degrees north of west if I want to use my cardinal direction. I could also say it's 40 degrees west of north. All three of these ways represent the exact same vector. But again, the convention is to use that positive x-axis. Given a certain vector, you should also be able to draw the vector out. Let's say I had a vector representing 40 meters per second at a 200 degree angle. This would represent a velocity, so I need to set my scale. So I'm going to say 1 centimeter represents 10 meters per second. The 200 degrees, remember, is measured from the positive axis all the way around. Here to here is 180, so I need to go an additional 20 degrees over. So I need to draw a vector that's 4 centimeters long, pointing at 200 degrees. So that would be an example of drawing a vector. There's one more step I would like you to do. You're going to go to physicsclassroom.com. When you're at physicsclassroom.com, click on Vectors and Forces of Motion in 2 Directions. Now I want you to look at this very first section. Read through this section. Again, it's just to reinforce what this video just went over. And try this vector direction page on the bottom. Okay, check your answers and make sure you're getting them right. If you have any questions, please ask them in class.